Welcome to Lesson 12, Integration by Substitutions, by Trigonometric Substitution. So in this lesson we learn how to solve this kind of problem when it appears a radical square root of 9 minus x squared. When you see these radicals, you will use substitution as x equal a sine of theta to solve the problem. Here, for example, on this problem, we will use, because it's of the type a minus x squared, we will use x equal a, which is 4, the square root of 16 sine of theta. In this kind of problem, that is a square root of x squared minus 25, we use substitution x equal a 5 secant theta. In this kind of problem, problem number 6, we use tangent theta. So, what is the summary of what I'm saying? Wherever it appears a radical that is a squared minus x squared, the correct trigonometric substitution to use is a sine of theta. If it appears a radical a squared plus x squared, the correct trigonometric substitution that will solve the integral is x equal a tangent of theta. And wherever it appears the square root of x squared minus a squared is different from a squared minus x squared, is x squared minus a squared. The correct substitution that will solve the integral is x equal a secant theta. Let's go now to solve problems. First problem says find the integral, find the antiderivative of the function 12 divided by 1 plus 9x squared. And this looks like an arctangent, so we say, okay, wait, there is not the square root of something, so we don't need to use what we said previously. We don't need to use a change of variable x equal a tangent of theta of this. Oh, because there is no radical. What will happen if we use the change of variable x equal a tangent of theta? We'll see later what will happen. So for the moment, we know that the derivative respect to u of arctangent of u is 1 divided by 1 plus u squared. If u is a function of x, the derivative of respect to the x of arctangent of u is the derivative respect to the u of arctangent of u multiplied by the derivative of u respect to the x according to the chain rule. So if u is 3x, the derivative respect to the x of arctangent of 3x is 1 divided by 1 plus the function squared 3x squared multiplied by the derivative of the function respect to the x, which is 3. So this means that the integral of 3 divided by 1 plus 3x squared, the antiderivative of this function, is arctangent of 3x. Because there is a 4 here, 4 by 3, you see there is a 3 here, 3, but here there is 12, so there is 4 by 3, 12. So there is 4 times 4 arctangent of 3x plus c is the final answer for this problem. So in this problem, indeed, what you are doing is you use substitution. You name u equal 3x, ddu is equal 3 ddx. So the integral of 12 plus 1 9x squared is 4 by 3 is 12. 12 ddx divided by 1 plus 3x squared, or which takes you directly to the antiderivative of the function, which is 4 times arctangent of 3x plus c. Let's go to try to do the substitution like we said, even if there is no radical. Let's go to see what happens. let's go to solve the same problem in a different way. These have no any square root in the denominator. They don't have any square root, but let's go to try to make the change x equal something a tangent of theta. But I don't see here the a. I see here the 9, so maybe we need to isolate the x squared and to do some algebraic manipulation. So let's go to divide the numerator and the denominator by 9. So it will appear 12 divided by 9, 1 divided by 9, and 9 squared divided by 9 is x squared. Now we'll take the 12 divided by 9 out of the integral, and the integral that I have to solve is 1 divided by 1 9 plus x squared ddx. Now I can see the a. The a squared plus x squared, the a is a square root of 1 divided by 9. So the change of variable, trigonometric change of variable that I will try is x equal a square root of 1 divided by 9 tangent of theta. So the ddx will be a square root of 1 divided by 9 by the derivative of tangent of theta, which is secant square of theta, dd theta. So this is the ddx. Let's go to plug in this information into this integral, or into this, that is the same one. Let's go to plug in here. It will be 12 divided by 9, 12 divided by 9, 1 divided by 9. Now instead of plugging x squared, I will plug x squared, or 1 divided by 9 tangent square of 9. What I will get here is that the denominator will be very easy to sum, and I will use the fundamental trigonometry relation, sine square of theta plus cosine of square of theta equal 1, or tangent square of theta plus 1 equals secant square of theta to solve this integral. So it will be 12 divided by 9, 1 divided by 1 divided by 9, 1 divided by 9 tangent square by ddx. ddx is a square root of 1 divided by 9 secant square of theta dd theta. So now I can do a little bit of algebra, and I will find that 1 divided by 9 plus 1 divided by 9 tangent square of theta, I can take common factor 1 divided by 9, it will be 1 divided by 9, 1 plus tangent square of theta. Secant square of theta, this square root of 1 divided by 9, I will put it outside, is here. And this 1 divided by 9 is 9. I would put it here, 9. 1 divided by 1 divided by 9 is 9. So it will have secant square of theta divided by secant square of theta, because 1 plus tangent square of theta is secant square of theta. So it will be the integral of dd theta. So the answer will be the 9 will cancel with the 9. So it will be 12 divided by square root of 9 by dd theta. Or 12 divided by 3 by theta, 12 divided by 3 by theta. But still we don't know what is theta. Oh, but we know that x is equal to square root of 1 divided by 9 by tangent of theta. So tangent of theta is x multiplied by a square root of 9, or 3x. So if I take the arctangent in both sides of the equation, arctangent of theta, oh, this is theta. This is theta. And I take arctangent of x square root of 3, square root of 9, which is 3. This is arctangent square root of 9 by x. So theta is arctangent of 3x plus c. So what is theta? So it's 12 divided by square root of 9 by theta, or in other words, 12 divided by square root of 9 by theta by arctangent of 3x plus c. Or 12 divided by 3, which is 4 times arctangent of 3x. And this should be the same result that we found in the previous in the same problem that we found before. Let's go to another. This integral is being solved by remembering that the derivative of the arcsine of u is 1 divided by the square root of 1 minus u squared. If the derivative of arcsine of u is 1 divided by the square root of 1 minus u squared, and u is a function of x, the derivative respect to the x of arcsine of u of x is, by the chain rule, the derivative respect to the u of arcsine of u multiplied by the derivative of u respect to the x. Then what I have is that the derivative respect to the u of arcsine of u is 1 divided by the square root of 1 minus u squared, multiplied by the derivative of u respect to the x. If we apply this to this problem with u of x equal x divided by 3, we find that the derivative respect to the x of arcsine of x divided by 3 is 1 divided by the square root of 1 minus u x divided by 3 squared, multiplied by the derivative of u respect to the x, or 1/3. So the derivative of u respect to the x of arcsine of x divided by 3 is nothing else than 1 divided by the square root of 9 minus x squared. This means that the antiderivative of this function is arcsine of x divided by 3. So the integral of 1 divided by the square root of 9 minus x squared is arcsine of x divided by 3. But let's go to try to do the problem in a different way. Let's go to use a trigonometric substitution like x equal a sine of theta. Let's go to try the same problem. So now the next problem is, just a moment, we start with the same problem, but we are going to try to solve it using a trigonometric substitution, because it appears the square root of 3 squared minus x squared, we will try the substitution x equal a sine of theta. The a will be 3 because a squared is 9. So let's go to try this substitution. X equal 3 sine of theta, so d dx will be 3 cosine of theta dd theta. Let's go to plug in this information into the integral, and this integral will be 1 divided by the square root of 3 squared minus x squared, but x squared is 3 squared sine squared of theta, multiplied by d dx, multiplied by d dx, multiplied by 3 cosine of theta dd theta. So it will be the 3 will go out of the integral. The 3 squared inside the square root, it will be 3 squared common factor of 1 minus sine squared of theta. 3 squared minus 3 squared sine of square of theta will reproduce this, multiplied by cosine of theta dd theta. Perfect. What is 1 minus sine squared of theta? Cosine squared of theta. What is the square root of cosine squared of theta? Cosine of theta. What is the square root of 3 squared? Is 3, is here. So it will be 3 divided by 3, which is 1. Cosine of theta divided by cosine of theta, which is 1. So it will appear only dd theta. So the integral of dd theta is theta plus c. Okay, but we don't know still what is theta. But we know that the x was chosen to be x equal 3 sine of theta. So sine of theta is x divided by 3. We create a triangle that will say that sine of theta is x divided by 3. Sine of theta is opposite divided by hypotenuse. So sine of theta is opposite x divided by hypotenuse 3. X divided by 3 is sine of theta. Now, if this is the hypotenuse and this is one of the sides of the triangle, Pythagoras' theorem will say that the length of the other side will be a square root of 3 squared minus x squared. Okay. So what will be sine of theta? Sine of theta is x divided by 3, and I don't need to do this triangle, but we will use this kind of triangle in the next problem. So if sine of theta is x divided by 3, what is arc sine of theta? Arc sine of theta, because arc sine is the inverse function of sine of sine. Arc sine of theta is theta. What will be in the other side arc sine of x divided by 3? So in the other side we'll obtain arc sine of x divided by 3. As a conclusion, I have found that theta is arc sine of x divided by 3. So the result of this integral is theta plus c, or arc sine of x divided by 3 plus c, and we have solved again the same integral using a trigonometric substitution, x equal 3 sine of theta. Okay, let's go to practice more this technique of trigonometric substitution in more problems. Now problem 3 says solve the integral of 1 divided by x square root of 4x squared minus 1. This look at our secant of 2x, because the derivative of our secant of 2x is this function, the derivative of this function. So let's go to do it in a different way. Let's go to find a trigonometric substitution that will solve this integral without, we remember that when it appeared, I said at the beginning when it appeared, something like this, x squared minus a squared, you use x equal a secant of theta. Let's go to do this integral using this trigonometric substitution. So you can do it as we have learned in previous lessons. You use this you use this chain of variables, u equal to x. You know that the derivative of arc secant of 2x is this function. Okay, let's go to try to do it using the new substitutions, the new trigonometric substitution. So what we have said that wherever we found an integral that appears square root of x squared minus a squared, use the change of variable x equal a secant of theta. This change of a trigonometric change of variable will solve the integral. So what is a? So the equation that they ask to solve is this, the integral that they ask to solve is this integral, the integral of 1 divided by x, square root of 4x squared minus 1. So the first thing that we have to do is to make to appear the radical like x squared minus a squared, and here it appears like 4x squared minus 1. So the a will not be the 1 because there is a 4 here. We need to get rid of this 4. So what we will do is we divide the numerator by 2 and the denominator by 2. So if we divide the numerator by 2, it will appear 1/2. If we divide the denominator by 2 and we go inside the radical, we divide by 4, because 2 squared is 4. So if we divide by 4 inside the radical, inside the square root, 4 divided by 4 will be 1, and 1 divided by 4 will be 1/4. So it will appear this integral. Now I can recognize x squared minus a squared. Being a squared 1/4 means that a is 1/2. Could be a plus minus, is true, but a is, we take it positive, 1/2. So what will be this integral? We solve this integral. It will be 1/2 the integral of 1 divided by x, square root of x squared minus 1/4 ddx. But who is ddx? Well, if x is equal a secant theta, we need to find ddx. Let's go to find ddx very soon. Let's go to arrange this equation. So the 1/2 will go out of the integral. It will be 1 divided by x square root of. So now we have to express the ddx in terms of theta according to to the change of variable where x equal a square root of 2 secant theta. This is the change of when x equal 1/2 secant theta. When x equal 1/2 secant theta, ddx will be 1/2. The derivative of secant theta is secant tangent theta. So ddx will be 1/2 secant theta tangent theta dd theta. So I will plug in this ddx into the integral. So I have this integral 1 divided by secant theta square root of 1/4 common denominator here that multiplies secant square of theta minus 1. Multiply by this, by ddx, that is 1/2 secant theta tangent theta dd theta. So now the magic of this trigonometric substitution will appear, and what will happen is that secant square of theta minus 1, if you remember, if you divide the fundamental trigonometric relation by cosine square of theta, you will find tangent square of theta plus 1 to divide by cosine square of theta equal 1 divided by cosine square of theta, which is secant square of theta. So tangent square of theta plus or secant square of theta minus 1 is tangent square of theta. So the square root of 1/4 will be 1/2. 1/2, it will be a 2 here, because 1/2 in the denominator means a 2 in the numerator. So it will be 2 times 1 secant theta, a square root of tangent square of theta. A square root of tangent square of theta is tangent of theta. So tangent of theta will disappear with tangent of theta. And secant of theta will disappear with secant of theta. And the 2 will cancel with the 2. Oh, so I have dd theta. I have the integral of dd theta. What is the integral of dd theta? The integral of dd theta is theta plus c. But we don't know who is theta yet. But we know that the change of variable is x equal 1/2 secant of theta. So secant of theta is 2x. So arc secant of theta will be r secant of 2x. So let's go to apply this, and we found who is theta. So if secant of theta is 2x, r secant of theta is theta. And this will be r secant of 2x, r secant of 2x. Conclusion, theta is r secant of 2x. So, because the integral, the result is theta, and theta is r secant of 2x, the final answer for this integral is that the integral that they propose us is r secant of 2x plus c. That is the same result that we found before. Okay, let's go to solve more problems. So now use this substitution directly. They say what is the substitution. Wherever you find a square root of a squared minus x squared in this form, you use substitution x equal a sine of theta. In this case, the a is the 4. So let's go to try to do it. Let's go to manipulate this equation. So x equal 4 sine of theta. So ddx is 4 cosine of theta dd theta. Perfect. So what is the integral that we have to solve? 1 divided by the square root of 16 minus x squared, everything to the cube. 3/2, everything to the cube. A square root, everything cube. So it will be 1 divided by square root of 4 squared minus x squared. X squared is 4 squared sine square of theta. 4 squared sine of square of theta to the cube multiplied by ddx, which is 4 cosine of theta dd theta. Now we make a little bit of algebra inside the square root, and this will be 4 squared that multiply 1 minus sine square of theta. But 1 minus sine square of theta is cosine square of theta, and a square root of cosine square of theta is cosine of theta. So at the end it will appear 4 squared with the square root would be a 4. 4 with the cube would be 1 divided by 4 cube. 1 divided by 4 cube, 1 divided by the integral of 1 divided by cosine of theta, because 1 minus sine square of theta is cosine of theta, but the square root of cosine square of theta, 1 minus sine square of theta is cosine square of theta, and the square root of cosine square of theta is cosine of theta, so it would appear cosine of theta cube. So let me write like this, cosine of theta cube, and remember that cosine of theta cube is the same thing that cosine cube of theta. We write like this. Okay, so one cube, one cosine of theta will cancel with this cube, and will appear 1 divided by 4 squared. 1 4 will disappear, so it will be 1 4 squared, 1 divided by cosine square of theta dd theta. So it would be 1 divided by 16 by the integral of secant square of theta dd theta. But this integral of secant square of theta is tangent of theta, because the derivative of tangent of theta is 1 divided by cosine square of theta, or the derivative of tangent of theta is secant square of theta. So it will be 1 divided by 16 tangent of theta. Now we arrive to a very subtle question that we have not finished yet to solve the problem. We didn't say who is tangent of theta, but we know the information. The information says that x equals 4 sine of theta. So we will plug this information in a triangle. The rectangle, this triangle, the right angle triangle, will say that sine of theta is x divided by 4. From this equation, what it says, sine of theta is x divided by 4. But sine of theta is opposite divided by hypotenuse. So the x opposite divided by hypotenuse, the x is the opposite, the hypotenuse is the 4. So if this is true, the other side should be, by Pythagoras theorem, the square root of 4 squared minus x squared. So what is tangent of theta? Tangent of theta is the opposite divided by the adjacent. So tangent of theta is x divided by square root of 16 minus x squared. Now we plug in this information on the integral, and the final result will be 1/16 tangent of theta, x divided by the square root of 16 minus x squared plus c. And we have solved the integral. Now you can make the derivative of this function, and you will find that the derivative of this function is the integrand. The integrand 1 divided by 16 minus x squared 3/2. Okay. And the problem is solved. So if you follow, the most important thing is what I have said at the beginning of this set of problems, that what kind of substitution you will use for every problem. Let's go to the problem. The next problem say like this. It say use substitution. It say the substitution that you have to use. So what I have said is that if you encounter a square root of a squared minus x squared, use substitution x equal a sine of theta. If you encounter a squared plus a plus x squared, use substitution x equal a tangent of theta. And here what we found is x squared minus 25, that is different than this. If you find if you encounter a problem with a square root of x squared minus a squared, use substitution x equal a secant of theta. So in this problem we need to use this substitution, because the square root that appears is x squared minus 5 squared. So so the problem says find the integral of x squared minus 5x squared divided by x. So we use trigonometric substitution at x equals 5 secant of theta. So d dx is 5 secant theta tangent theta dd theta, because the derivative of secant theta is secant theta tangent theta. So if we plug in this information into our initial integral is this one. So we plug in the information wherever it is appear dx, we put 5 secant of theta, so it will be x squared 5 squared secant squared of theta minus 5 squared divided by x. X is 5 secant theta by ddx. ddx is 5 secant theta tangent theta dd theta. Now the magic will appear. We use secant square of theta minus 1. Sec is tangent square of theta. Secant square of theta minus 1 is tangent square of theta. You remember using Pythagoras theorem of the fundamental trigonometric relation. You divide by cosine square of theta, all this equation, and it will if you divide by cosine square of theta, it will appear a 1 here. Here will appear a tangent square of theta. Here will appear secant square of theta. So secant square of theta minus 1 is tangent square of theta. So here is tangent square of theta, but there is the square root, so it's tangent of theta. So basically, what we have transformed is that this secant of theta will cancel with this secant of theta. Inside the numerator, inside the square root will appear tangent square of theta, which is tangent, the square root of tangent square of theta will be tangent theta. So this 5 will cancel with this 5, and the square root of 5 squared will be 5, and this is this 5. So 5, so tangent of theta, secant of theta will cancel with this, and it will appear 5 times tangent theta, or 5 times tangent square of theta, or 5 times secant square of theta minus 1, or 5 times the integral of secant square of theta minus the integral of dd theta. But the integral of secant square of theta is tangent theta, and the integral of dd theta is theta. So the final result will be 5 tangent of theta minus theta plus c. But this is not yet the final result, because we didn't say we need to express this solution in terms of x, but we know that the change of variable that we have used is that x is equal 5 secant of theta. So now we need to express this solution as a function of x, because x equal 5 of because the change of variable that we have used is x equal 5 secant of theta. We know that secant of theta is 1 divided by cosine of theta, of course, but secant of theta is x divided by 5, x divided by 5. So cosine of theta is 5 divided by x. So cosine of theta is adjacent 5 divided by hypotenuse x. So this is the adjacent, this is the hypotenuse, so the other side is hypotenuse squared minus 5 squared, a square root. So this side is a square root of x squared minus 5 squared. So what is tangent of theta? Because I'm looking for what is tangent of theta, and I'm looking what is theta. So tangent of theta is opposite divided by adjacent. So tangent of theta is a square root of x squared minus 5 divided by 5. So I will plug in tangent of theta here in terms of x. And who is theta? Well, I know that secant theta is x divided by 5. So if I take our secant of theta is x divided by 5. So r secant of theta is equal to r secant of x divided by 5. But r secant of theta is theta. So theta is r secant of x divided by 5. As a final result, 5 tangent of theta minus theta would be 5 square root of x squared minus 5 divided by 5 minus theta minus r secant of x divided by 5 plus c. And now the problem is solved. So we have obtained that the integral that they propose us is this one. The antiderivative of the function that they propose us is this one, in a way that if you do the derivative of this function, you will obtain this function, of course, this function. Now let's go to the next problem. The next problem says, use substitution x equal tangent of theta to find the definite integral of x squared 1 plus x squared squared. So we use it. We use it because this is the pattern that they say. Whenever you find a square root of a squared plus x squared, use the change of variable x equal a tangent of theta. It's true that here doesn't appear the square root, but you imagine that it will appear like this, and it will be the same, or like this to the 4. A square root of this to the 4 will be the same that this denominator. So we use x equal tangent of theta as the problem says. So d dx is secant square of theta d d theta. So we plug in the information. X squared divided by 1 plus x squared, everything squared d dx is x squared, a squared tangent of theta, but a is 1. They say to use this relation, tangent square of theta 1 plus x squared plus tangent square of theta, everything square, multiplied by d dx, but d dx is secant square of theta d d theta. So what is 1 plus tangent square of theta? Secant square. Secant square square. Oh, secant square is secant 4. Yes, it's secant 4. So secant 4, and this is secant square, will appear as secant square here in the denominator. So it will be tangent square of theta divided by secant square of theta. Tangent square is sine square divided by cosine square. Divided by secant square of theta, that is 1 divided by cosine square of theta. The cosine square will disappear and will appear only the sine square of theta. So it will be the integral of sine square of theta d d theta. Integral of sine of square of theta d d theta is done in a previous problem, and is done by using the trigonometric relation that sine square of theta is 1 minus cosine of 2 theta, double angle, divided by 2. So we use this equation to solve sine square of theta. If we use this equation to solve it, we have 1/2, this 1/2, the integral of d d theta minus the integral of cosine of 2 theta d d theta. So this will be 1/2 theta minus 1/2 sine of 2 theta plus c. Now we remember that the sine of a plus b is the sine of a cosine of b plus sine of b cosine of a. If theta, sine of 2 theta, sine of theta plus theta, which is 2 theta, is sine of theta multiplied by cosine of theta plus sine of theta multiplied by cosine of theta, or 2 times sine theta cosine of theta. So sine of 2 theta is 2 times sine of theta cosine of theta. So the 2 will disappear now. So we will have 1/2 theta, and now the integral of cosine of 2 theta is 1/2 sine of 2 theta, or sine theta 1/2 sine theta cosine of theta. So the integral will be 1/2 theta minus 1/2 sine theta cosine of theta, which is sine of 2 theta. So now the problem is not yet solved. We need to express the final result in terms of x, but we know that the x is tangent of theta. So the x is tangent of theta. So theta is r tangent of x, but we don't know who is sine of theta and cosine of theta. We know who is theta. Theta is arctangent of x. So the first part of this equation will say 1/2 arctangent of x. Now we need to find sine of theta and cosine of theta. Because the x is equal tangent of theta, and tangent of theta is opposite divided by adjacent, so it should be x divided by 1. So tangent of theta is x divided by 1. Tangent of theta is x divided by 1. So this is the hypotenuse. So the hypotenuse will be a square root of 1 squared plus x squared. So what I have to find is sine of theta. Well, sine of theta is opposite divided by hypotenuse. So x divided by square root of 1 plus x squared. Multiply by cosine of theta. What is cosine of theta? Is adjacent divided by the hypotenuse. 1 divided by the square root of 1 plus x squared. And now I found the final result. The final result is all this 1 plus c. And now the integral that they propose us is solved using a trigonometric relation, that is x equal tangent of theta. Let's go to the next. The next problem is more of the same technique to practice. It says evaluate this integral, the integral from 0 to a square root of 3 divided by 2, x squared 1 minus x squared raised to 3/2. So it's the square root of 1 minus x squared to the cube. So when it appears something in this form, 1 minus x squared, the chain of variables that we will use is x equal a sine of theta. So x equal 1 sine of theta. And d dx is cosine of theta d theta. Let's go to our integral. The integral of x squared 1 minus x squared 3/2 d dx. Who is x? Sine of theta. Who is x squared? Sine squared of theta. Who is d dx? Cosine of theta d theta. Who is 1 minus x squared? Is 1 minus sine squared of theta 3/2. But 1 minus sine squared of theta is cosine of theta. So it's cosine squared of theta. With this square will be a cosine cube of theta. So we need now to be sure that we plug in this is theta equals 0. From when x, we need to there is a chain of variables. So when x, because the chain is x equals sine of theta, when x equals 0, the angle whose sine is 0 is theta equals 0. When x equals square root of 3 divided by 2, sine of theta is a square root of 3 divided by 2, or theta is 60 degrees, is pi divided by 3. So the integral now changes, is from x equals 0 to x equals square root of 3 divided by 2 to theta equals 0 to pi divided by 3. So let's go now to finalize this integral. So it will be the integral of sine squared of theta divided by 1 minus cosine cubic of theta. This is cosine squared. The square will go with the cosine squared. The square will go with the square root. This is square root. So it will be cosine cube of theta, sine square of theta. So 1 cosine of theta will go out of this, and I will have sine square of theta divided by cosine square of theta, which is tangent square of theta d theta. Now, to do this integral, we did it in a previous problem. Tangent square of theta is secant square of theta minus 1. So I will integrate this expression. But the integral of secant square of theta d theta is tangent of theta, and the integral of 1 by d theta is theta, between theta equals 0 and theta equals pi divided by 3. So the final result will be tangent of pi divided by 3 minus pi divided by 3 minus tangent of 0 minus 0. So the final answer will be tangent of 0 is 0, and when theta is 0 is 0, so it will be tangent of pi divided by 3 minus theta minus pi divided by 3. But tangent of pi divided by 3 is the square root of 3 minus pi divided by 3, and this is the final result. Let's go to the next problem. Next problem. Okay, the next problem say like this. It say like this. It say, solve the differential equation square root of x squared plus 4 multiplied by the derivative of y respect to the x equal 1. So the equation that they are asking us to solve is the derivative of y respect to the x equal 1 divided by the square root of x squared divided by 4. So if you pass this d dx to this side and you integrate in both sides, you will have this integral, the dy d dx. Well, if you pass d dy equal 1 divided by the square root of x squared plus 4 d dx, what they are asking me is who is y? Who is the integral of d dy? Is y. Who is the integral of 1 divided by square, or 1 divided by the square root of x squared plus 4 d dx? Well, it's y, but what is that? What is this integral? To do this integral, because it appears x squared plus 4, we will use a tangent of theta, 2 tangent of theta. So the chain of variable that we will use is x equal 2 tangent of theta. Who is d dx? d dx is 2 secant square of theta d d theta. Who is x squared plus 4? Is 4 times tangent square of theta plus 4, or 4 times tangent square of theta plus 1, or 4 times secant square of theta, because tangent square of theta plus 1 is secant square of theta. So the equation that I have to solve is d dy divided by d dx equal 1 divided by the square root of x squared plus 4. But the square root of x squared plus 4 is 2 secant theta. So this is the equation that I have to solve. So d dy will be 1 divided by 2 secant of theta d dx. But d dx is 2 secant square of theta by d d theta. So 1 square will cancel with the other secant, and the 2 will cancel with the 2. So I will finalize that d dy is secant of theta d d theta, or y equal the integral of secant theta d d theta. But the integral of secant theta we already saw in a previous problem is natural log of secant theta plus tangent theta plus c. So y is natural log of secant theta plus tangent theta plus c, but the problem is not yet solved. We need to know what is secant of theta, but we know that tangent of theta, x equal 2 times tangent of theta, so tangent of theta is x divided by 2. We construct our triangle. Our triangle will say that tangent of theta is x divided by 2. Opposite divided by adjacent. So the hypotenuse will be a square root of 4 plus x squared. So because here will appear secant of theta is hypotenuse divided by adjacent. So I will put hypotenuse, the square root of x squared plus 4 divided by 2, plus tangent of theta, but tangent of theta is x divided by 2 plus x divided by 2 plus c. And now, wow, the problem is not yet solved, because the problem say that they are giving you an initial condition. So we need to fix the c. The initial condition is that of 0 is equal 4. So when x equals 0, y equals 4. So we go to our result that we found here, and we plug in the initial condition to solve for c. So the result that we found is that the y is the natural log of this expression plus c. We can manipulate this expression to obtain something like this, I'm going to be a little bit short, something like this, and from here we can work the initial condition. It says that when x equals 0, y equals 4. So we're plugging 4, x equals 0, so square root of 2 plus 0 plus c. And this allows me to find the c. The c will be, this natural log of 2 will cancel with minus natural log of 2, then the c will be 4. So finally, the final result for this problem is that the y of x is c, which is 4, plus minus natural log of 2 minus natural log of 2 plus natural log of x squared plus x, square root of x squared plus 4 plus x. And this is the final result. As always, you can make the derivative of y respect to the x, and you will have to find what? You will have to find 1 divided by the square root of x squared plus 4. 1 divided by the square root of x squared plus 4. And if you don't believe me, you try. The problem is ask you to find the arc length of the curve 1/2 y equal 1/2 x squared between 0 and 4. The curve 1/2 x squared is a parabola, and when x equals 4, y equals 8, and for sure the length is longer than this distance. Is longer than this distance, that is 4 squared plus 8 squared square root. So the length that we have to find is bigger than this distance. Let's go to apply our equation for the length, the arc length of a curve. The equation for the arc length of a curve is that s is the integral from x equals 0 to x equals 4 of the square root of 1 plus y prime squared ddx. Why this problem is interesting is because appear an integral that can be solved using integration by trigonometric relations, like x in this case is x tangent of theta. So it will be the square root of 1. Y of x is 1/2 x squared. So y prime is x, plus x squared. And this integral is the kind of integral that we are dealing. We are solving by using the substitution, the change of variable x equal tangent of theta. So d dx is secant square of theta by d d theta. So the arc length s from 0 to 4 will be the square root of 1 plus x squared plus tangent square of theta d dx secant square of theta d d theta. But the square root of 1 plus tangent of square of theta secant square of theta. So the square root of secant square of theta is secant theta. So the integral will be secant theta secant square of theta d d theta. Wow, it will be the integral of secant cube of theta. How I will solve the integral of secant cube of theta d d theta. Wow, we use integration by parts. So if we use integration by parts, you can see here how it's been used. Secant theta is u. We use integration by parts. We name u like secant theta, and ddv, secant square of theta ddx. Secant of x, well, instead of theta, I'm writing dx. We'll change it to the theta again, to the theta universe later. So u by ddv. So u is secant of x. ddv is secant square of x ddx. So ddu is secant tangent of x ddx, and v is tangent of x. Using integration by part, u by v minus the integral of v by ddu. V is tangent of x by ddu, which is secant tangent of x, will appear tangent square of x, secant of x. Okay, if we do now, we need to do integration by part twice to do this integral. So it will be secant x, and you don't have to worry about this because to do integral is an art, but today your computer or your calculator will tell you the integral. So it's not so important to know how to solve the integral of secant cube of x. Just practice a little bit integration by parts, and integration by part will solve. So it will be secant tangent minus the integral of tangent squared, which is secant squared minus 1 secant of x. So now will be minus secant cube of x minus secant x. Wow! And now this secant cube of x will go to the other side, because what we are solving is the integral of secant cube of x ddx. So with this minus will appear 2 times secant cube of x equals secant x tangent x minus the integral of secant x tangent x. So finally, the integral of secant cube of x ddx will be 1/2. These two will be 1/2 secant x tangent x u by b, plus the integral of secant x ddx that we have solved in class, that is natural log of the secant x plus tangent x plus c. Wow, we converted to theta because I made the mistake to put the x, so the integral of secant cube of theta dd theta is 1/2 secant theta tangent theta plus natural log of secant theta tangent theta plus c. And still the problem is not solved yet, because we need to find who is theta, but we know that x is tangent of theta. So if the x is tangent of theta is the opposite divided by the adjacent. So x divided by 1, the adjacent should be 1, and the hypotenuse should be square root of x squared plus 1. This allows me to find secant theta, tangent theta, secant theta, tangent theta. So if I express the final result, will be this one, the final result. And if I plug in number between 0 and 4, when it's 0, everything is 0, because it appears 0 here. 0 plus 1 will be 1, square root of 1 will be 1, but natural log of 1 is 0. Here will be 0. So the point that give value to the arc length is the point x equals 4. If you plug in, you will obtain this number, a square root of 4 squared 16 plus 1 17 multiplied by 4 plus the natural log of a square root of 17 plus 4, x equals 4. And this number should be more, a little bit more, than the square root of 8 squared, square root of 8 squared plus 4 squared. I think this number should be like 10, something like this. Okay, you check it. That's all. I'm sorry that it's too long. I'm sorry that I have a lot of calculation here, but that's it. That's it. I cannot do it in any different way. Good luck, and the important thing is to know what substitution, what trigonometric substitution you have to use in every case. This is the most important thing. Okay.